Apache Cassandra is a database that focuses on reliable performance, speed, and scalability. It quickly stores massive amounts of incoming data and can handle hundreds of thousands of writes per second. But before we move on to the session, please make sure that you're subscribing to our YouTube channel and enabling that bell icon so that you will never miss any updates from Intellipaat. So without any further ado, let's get to today's agenda. First comes the features of Cassandra, and then comes the limitations of RDBMS, and then its probable solutions. And after that comes the NoSQL, then comes the NoSQL Database Types, and then comes Cassandra Architecture, and then comes the history of Cassandra, and then finally for the last topic of this session, why Cassandra?
There is lots of difference when you work on a product or you work on a project, right? So yeah, that is me. In Apache Cassandra, I am data stack certified professional, uh, and training wise, I have delivered around more than 50 sessions in Apache Cassandra. And apart from Apache Cassandra, I also do train for other NoSQLs as well. Like one of them is MongoDB. Okay, so in Apache Cassandra, I have trained more than 800-900 people, including the corporate ones, and I have more than 95% positive feedback. That was about my trainer profile. So let's get started with the course. So I will just give you an idea of the course. Definitely, I am not a person that like to go with the written PPTs or so. We will be seeing the PPT, but just to verify the content. Okay. So, guys, just want to have little bit introduction about you. Means what you do, how much experience you have, in what area you have experience, or you have any big data exposure, and most important thing, what is your expectation from this course? So, Mulish, let's start with you. Okay, so let me tell you how we are going to start because you people are kind of new to big data. So let's first understand what we are learning here. Okay, we are trying to learn here Cassandra. So what is Cassandra? Cassandra is a database, particularly it is no SQL type of database or no SQL type of database, right? And what is NoSQL? NoSQL is a set of databases or set of technologies that are introduced to solve problem of big data, right? So in order to understand or Cassandra, we need to first understand NoSQL. And in order to understand NoSQL, we have to first understand big data. What is big data? Okay. So if I say that, okay, big data is actually not data. Of course, it is about data, but it is not data. Then how would you feel? Strange, right? So in my views, maybe it may be my personal view, big data is just a problem statement. Sorry guys, this is the driver problem that causes this program to crash. Let me just open it again. We have to keep saving it. As I said, so I will not go for at the corporate level, but let's say we have a PC, okay, that desktop PC, like our traditional ones. So here's the mouse. So this PC's configuration is I have 8-core CPU, I have 32 gigs of RAM, I have 1 terabyte of SSD. Okay, this is my configuration. Okay, 1 gigabyte of data. So it's pretty easy for this machine to process it. It will be doing it in fraction of seconds or at most in seconds. Okay, so yes, it may not be the big data use case, but let's say I tell you to process this data. So guys, do you recall your first cell phone? Not about smartphone, your cell phone. So previously, I guess 10 years back, 10-15 years back, we used to have button phone. My one was this one. Now I tell you, forget about the RAM. This guy used to hang, with just LCD screen sometimes. Okay, so uh, now I want to process this data by using this hardware. So can I say this is the use case of big data? So data is same here, but tools in hand are changed. So actually, big data is a problem statement that depends on how we are processing it. So basically, big data is a problem statement when processing of data becomes too huge or too complex to be fulfilled or processed by in-hand tools we have. So this we can say is the basic definition of big data. Okay, now sometime back people came with the concept of 3 V's. Okay, so if let's say you have a problem statement and you want to know whether this qualifies the use case of big data, so you can evaluate by using 3 V's. First was volume, second was velocity, and third was variety. But I think during year 2009 and 2010, IBM came with an article that added two more things: value and veracity. And now, I see people adding more V, 6V, typically considered as the visualization. But let's take these 5 V's as per the IBM standards as a standard. So let's talk about these V's. So the first one, volume, says is your volume is huge and it is continuously increasing. Okay, you have uh, probably volume in terabyte or petabytes, and it is not stable even then. It is continuously increasing. Okay, in that case, it may be the use case of big data. Let's say variety. Okay, we'll take velocity later. Variety is in our traditional systems. Okay, guys, it's gone again. So let me just, guys, I'm using Excel because on OneNote it used to crash the system. So volume, variety, velocity. I think this problem has to do something with my graphic card. I have dual graphic card. So probably this writing device got confused between which one to choose. And so I'm trying to find the solution. Value. So if you, I guess you are expert of the traditional RDBMS databases, and the classic is Oracle, right? So if you think about our RDBMS use cases, you must be knowing that most of our data was relational, or we can say textual, right? But now we are getting data in multiple formats. It can be a video file, it can be audio, it can be your server logs, it can be emails. If it is social media data, it can be, what do you say? It can be your Facebook post, your tweets, news articles, anything. So, so basically, your database should be able to handle all this variety of data. Okay. Velocity says that your data is coming at very high rate. So let's take an example. Let's say that I guess you people have must heard about this term called predictive maintenance, right? This is the new thing in a new thing, or I think in States or Europe, it is kind of becoming established technology. So what they do is, let's say you have an SUV, okay, this is your spare wheel, right? Let's say you have an SUV, and it's an expensive one, okay? So now a company comes to you saying that, okay, if you're going on a road trip, there can be possibility that something happens with your car and it may break down. So what we will do, we will set up some sensors all across your car. Okay. And these sensors will give us some readings. So they have some servers. These readings will go to these servers, and if there is some abnormal behavior or abnormal readings in your car, they will just give you an alert that there's a possibility of sudden breakdown. There is something wrong with your car. Just go to the nearest workshop. Okay, so they are actually predicting a big breakdown. Okay, now let's take an example. Let's say my car has some 100 odd sensors fitted, and let's say each sensor is giving a reading in 5 seconds. Okay, so in 5 seconds I'm going to have 500 readings, right? And let me open the calculator. Let me just plus first save this guy. So in 500, so in 1 minute I'm going to have how many readings into 12, and in 1 hour I'm going to have these many readings. Okay, sorry, 6,000 into 12, sorry, 6,000 into 60. So if a company want to earn some profit from this model, so let's say a mid-sized company or big company is monitoring at least 100,000 cars. So you can just multiply it into 100,000. So your company server will be getting these many readings in an hour, or we divide it by 60 to get in minute. Okay, so this is huge, right? So this is about velocity. Data is coming at very high rate, and your system should be able to handle that. Okay, now next V is about value. Okay, now let's take an example. You created a data store that is able to meet all these three requirements. Okay, volume, velocity, variety, and velocity. But does it make sense to invest that much if it is not able to generate value out of it, right? So value generation basically has two parts, or two basic asks. First is your system should be able to generate value. And value, typically, whenever we generate value out of the data, that value generation has a context with time. So the value should be generated on time. Now let's take an example. Let's say you took your new SUV to a road trip. Okay. So if you wonder why this guy become this is just the top view of it. Okay. Okay. You went on a road trip, right? Now let's say that your engine temperature sensor started getting some abnormal reading, giving some abnormal reading. This reading goes to the company's central server, and it says, it detects that okay, your engine temperature is greater than the threshold, right? So this is data, and now it will detect okay, engine temperature is raising. Probably this is the issue. There's some issue with your engine. Okay, and if you don't get it fixed, you may face a breakdown, right? So what the server will do, this will add this data that it has generated. So it will just create a notification for you. What this notification will be, it will combine with combine with this data with your location, and it will tell okay, take exit 10. There's some issue with your car's engine, take exit 10. There is a workstation or there is a workshop, and get it fixed. Otherwise, you may face a sudden breakdown, right? So you will get this notification. So this is about getting the data and generating value out of this data, right, guys? Now, let's say that when the company server was processing this data and combining this, it was too busy. Okay, too busy due to the load, and so it took some 1 or 2 minutes to do all this thing. Now it says that, okay, take exit 6, but you have already passed exit 6. Although the value is generated and it was kind of correct, but this value is of no use. If you are on expressway, probably you cannot take U-turn in next 100 miles, 50 miles, right? So value was generated, but this value is of no use because it was not generated on time. Right, guys? Make sense? So first or basic ask is value should be generated. Your system should be able to generate value from the data, and it should be generated on time so that it is still relevant to the users. Okay. Now let's take now let's discuss the last V, that is about veracity. So veracity is about correctness of data, or it is about data inconsistencies. Okay, so it is about correctness of data and about data inconsistencies. Okay, uh, let me choose this pen. So whenever you are getting data or bulk data from a raw data source, there is always a chance that data may have some inconsistencies or the data is not correct. Okay, so again, this problem also have two parts. First is, how do you find the data inconsistency? And second part is, how do you handle that? That is, what do you do about it? Right? So let's discuss in the same use case. Now let's say the engine temperature you are getting, okay? That engine temperature is greater than your threshold. Now let's say the problem was not there with the engine, okay? Actually, the temperature sensor was faulty and it was giving you the wrong readings, okay? So probably if your temperature sensor was faulty, probably that's not a big issue, although it's an issue, but it will not give you, it will, there are very less chance of having a sudden breakdown, or probably you may drive 100 more miles with the current situation, right? So how do we, first challenge is, how do we detect this data inconsistency? So again, guys, this part is kind of complex. It depends on domain to domain, or it depends on particular situation. Okay, so in this case, let's say typically we set up some ground rules or some business rules. In every system we have that to validate the input data. Okay, or we have multiple sources to validate a particular data point. So for example, if your engine is getting some issue, if there is something wrong with the engine, temperature is not the only parameter that will change. Okay, probably your vibration sensor will give some abnormal reading. There will be some abnormal noises, abnormal vibration, or probably your exhaust status will be changed. If your engine is not on your 100% efficiency, then definitely it will throw some unburnt fuel also, right? So by combining all this data, you can actually find out whether this temperature is faulty, or or your engine is faulty. Okay, so this is in this situation. Again, guys, this depends on domain to domain how you are going to do that. In this situation, this is answer of how to detect it, right? So now what to do about it? Okay, probably this temperature sensor, it is a small part, and there is very less chance that it will go it is going to it will go out of order. So typically the workshop here, let's say W1, it is a small town workshop, or it is just a highway pit shop. Okay, and it does not have these small parts of specific model. Okay, so your company server may check the inventory of the shop, that okay, this workshop doesn't have this spare part. So, and that this is the issue with the sensor. So probably it is not a serious issue. You can drive maybe 50 or 100 more miles, and you can take exit 15 when there is a big workshop, and the part you desire is available here, right? So probably you can just say that okay, there's some issue with your temperature sensor. There is nothing serious. You can still drive 100 more miles. There are very less chance of getting a failure or breakdown. Take exit 15 to get it fixed, right? So this is about how you are going to handle that. Now let me just open the PPT. Sorry guys, this PPT are a bit old, and I recently discovered they are not that good structured as well. So I may skip few. So now guys, with these use cases of big data, our traditional system started getting some issues. Let's discuss what is the issue. So now guys, is there a thumb rule that if big data use case is there, it has to be handled by a NoSQL only? Or is it written somewhere that RDBMS cannot handle a big data use case? No, right? We can do that. But the issue is when we try to do that, they will be high cost, because these systems, the RDBMS systems, are not natively designed to handle this volume of data. So it will be a massive overhead, and they will be high cost. There may be poor performance while processing the large amount of data set. And again, when your data set outgrows the single machine's capacity, you may have to shard it across multiple servers. That is horizontal sharding. Horizontal scaling, right? So in that case, our RDBMS data model. So basically, guys, your RDBMS data model is the normalized data model. And if your data model is normalized, so obviously to get a consolidated view of an entity, you will be making joins, right? So just think about it. If your data is sharded, let's take a classic case of employee department data, right? So if you're firing that query of select e dot name and d dot department name from e employee d department, where e dot department id equals d dot id. Okay, so this is a simplest case of join. Now let's say your employee data is on server A, and your department data that is you are joining with is on server B. You can just think about the latencies, right? So joins are good to have, but they do not perform on the distributed data set. Okay. And on top of that, you will have rebalancing issues. Okay. So again, caching layer problem. Most of the data RDBMS used to have an external caching layer problem. Okay. If you implement sharding in RDBMS, then along with the data, you will have to think about how you are going to balance this caching layer. Okay. Scalability. Most of the RDBMS, I'm not saying all, most of the RDBMS supports horizontal scalability. Sorry, vertical scalability. My bad, guys. Vertical scalability. So first of all, what is scaling or what is scalability? So scaling is a situation when your existing system is not able to fulfill your request. Let's say you are getting out of storage error or out of memory error, or your performance is not good. So you may want to improve on compute or RAM. So improving your existing system is known as scaling. Okay. So what is our typical way of scaling or traditional way of scaling? If we are getting out of memory error, out of storage error, we will add more disk, right? If we are getting some performance issue, we will add more RAM. We will add better CPU, or if it is a server machine, we will add more CPUs. right? So this phenomena is known as vertical scaling or vertical scalability.
Okay.
So what we are doing here is we are just upscaling or scaling up the existing hardware, right? This is also known as scaling up. Okay. Now, if you think about it, this is a good approach. This is simple, but in some cases, it may be up in some instances, it is cheaper also. Okay. I will tell you when we discuss the other type of scaling. Uh, but it has a limitation. Okay. You cannot add 100 CPU in single motherboard, right? You just can't do that. There's a physical limitation. So basically, vertical scaling has a limit. Okay, in terms of hardware you can add, you cannot attach 100 disk to a PC or to a server, right? You cannot attach infinite RAM to a server. So we are talking about big data where we may require infinite scaling, right? You cannot predict the volume yet. Okay, so that has a physical limitation. So to counter that, we have another type of scalability, that is horizontal scalability, or it is also known as scaling out. Okay, so in this type, what we do is instead of scaling the existing hardware, we just add more servers with similar or better capacity. Okay, so it has multiple benefits, like it is infinite. You can add as many numbers of the machines you want if the underlying technology supports that. Okay, and also if you are adding more number of machine, it is also improving your availability. So if one box is down, others are up. Okay, or if your data is sharded, if so previously if this box was down, this box goes down, you are 100% unavailable, right? But if in this case, if your data is sharded, if out of 4 1 is down, you are just 25% available, unavailable, right? 75% of your data is still available, right? Again, this can go up to 100% in case you are having replication. Okay, just guys, it went again. Okay, sorry. Okay, horizontal scaling. So horizontal scaling is adding more machines, right? So if we talk about the big data use case, horizontal scaling is the way. Okay. We have another type of scalability that is typically known as elastic scalability. So what is elastic scalability? So elastic scalability is something, it is like elastic. Okay. If you talk about vertical or horizontal scaling, they just talk about scaling up. But elastic scalability also talks about scaling down. So it is the special case of horizontal scalability. It is the type or subtype of horizontal scalability where what you're doing, it says that your cluster can be scaled up or scaled down whenever required at any point of time without any downtime. So both of these operations should be supported without any major downtime. Okay. So basically scaling for the big data use case, we require horizontal scaling or elastic scaling, but most of the RDBMS are compliant towards vertical scaling only. Okay. So structure of data. So we can have different type of data. We'll see in the next slides. We can have unstructured data, semi-structured data, quasi-structured data, but our traditional RDBMS are compliant towards only for the structured data. Okay, so these are some of the limitations of RDBMS when our problem statements relates to the big data use case. Okay, I'm not saying these are the problems. These are the problems when it comes to big data use case. Okay. So what can be the probable solution? So let's say to solve this problem, we require these properties. So scalability, I require a system that supports elastic scalability, right? Should not run out of memory. So guys, just think about it. If you are running a company like Facebook, at any point of time, can you predict how large it will be, right? I think Facebook is multiple times larger than what it was in year 2012, right? So is there any chance they could have predicted that, right? No. So we require a system that should never run out of memory, or it is infinitely scalable, right? High availability. So if you are in B2C domain, so every second of downtime will cost you customers. So you have to be 100% available, as much as 100% available, as close as I'm.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job.
Yeah, again, 100% availability is not guaranteed, never guaranteed, but as close as 100% available all the times. Automatic sharding. So first thing, your system should support sharding, right? Sharding, what is sharding? Sharding is the phenomena when you spread data across multiple servers. So if you have to store 100 values, 1 to 25 may be stored here, 26 to 50 here, 51 to 75 here, 76 to 100 here. So dividing data across multiple servers is known as sharding. So basically, it should support sharding, and the sharding should be automatic. Okay, it should not be like each time you're adding a server or removing a server, you are adjusting your sharding configuration. Okay, fault tolerance. Your system should be able to withstand some machines down. So if you are horizontally scaled up, you will definitely, you are going to have multiple machines. And if you have multiple machine, no matter how much money you spend, you cannot guarantee that this machine will never go down. Okay, it can go down, anything can go down, right? Even though your machine is perfect, your network is perfect, what will you do if some storm hit your data center, right? If it is flooded, right? You can never assure 100% uptime for anything. Okay, so your system should be able to handle that. If some of the nodes goes down, it should be able to handle that. It should remain operational even with some nodes going down. Sharding should not create problem. So again, while adding or removing the node, it should not create problem or imbalance in the cluster. Okay, cost effective. Everything has to be cost effective. I guess you people are, have very good experience with Oracle. I think right? In Oracle, when you are setting up the Oracle database, they come up with some specification. We need this CPU, this type of memory, this type of storage, right? Have these things, we can say that okay, this will perform well. But if you don't have it, we cannot assure you. Probably it will even not work in the extreme scenario, or at least they will say we cannot guarantee the performance, right? So you are giving a great amount of money for licensing, right? So you don't want to save money here, right? So you will buy that. Let's take an example. I think it happens also. Let's say Oracle has implemented a new type of CPU with collaboration with Intel, and they claim that this CPU will give the optimal performance on Oracle database, right? So now these guys are very clever. So Intel know that if you are purchasing this CPU, this X CPU, so you are definitely Oracle customer and you don't have a choice. So they may inflate cost of the CPU, right? If its actual cost is, let's say, $500, they may ask you $1,000 because you do not have a choice. Okay, you want to set it up, you require that. you will buy it at any cost. Okay, so that is a case that typically these traditional or licensed system comes up with a specific hardware or software requirement that may incur additional cost. So the solution has to be cost effective in the sense it should run on commodity hardware. So commodity hardware means it doesn't mean that you can run your production server on a laptop, although you can do that. But you can just imagine, right? Laptop cannot give you that much performance. So what it says by commodity hardware is, uh, you can have any hardware of your choice, and it will work. It will work as per your money spent. We do not demand any specific hardware. If you give it, it's your choice. It will give you good performance. So you can take an example. Okay, let's say I'm buying a PC. Okay, so I know, I don't know whether you have the idea or not. In Delhi, we have a market called Nehru Place. Okay, there we can, in our college time, where what we used to do, we used to, it was early 2000. So I know that is recent for you, but for us it was our childhood, guys. Okay, so we used to assemble the PCs for our labs. Okay, so there, let's take an example. Let's say I am I have two CPU options, i3 and i5. Okay, now i3 is costing me $100, but because i5 is kind of popular one, and Intel is producing it at large scale. So i3 is 2 cores and i5 is 4 core, so it is having double core, right? But because i5 i3 is the outdated one, so Intel might have cut down the production, and i5 is the kind of popular one, not the latest but popular one. So so because production is huge, they have very good stocks, so they are just giving it in $120. So you are getting double performance in just 20% more price, right? There is always a case whenever you go to shop a PC or shop a server. There is always a case where a certain model is in huge stock, and price wise, with a little addition of cost, you can get almost double of the performance. Okay, so if you do not have these kind of constraints, you can probably save some money there. Okay, and instead of just relying on a single server, you can have multiple smaller servers. So guys, the idea here is not to have too much constraints, or not to become too much choosy in terms of hardware or the software requirement, and be little bit flexible, so that we can save some cost here. And the last requirement is processing should be fast. Okay, so over all of these things, processing should be fast. Okay, so the probable solution can be a NoSQL database. So NoSQL was a term that was introduced in one database conference, I think during year 1999. So it was the term initially introduced for the database that are not based on the relational principles, or that are non-relational. So later on, this term was renamed to not only SQL. So now this emphasizes that they are the class of databases that may support SQL-like query language, and they provide some more features. Okay, what are the features? They are typically schema agnostic. So there is no fixed schema, or if you think about it, when you work with the RDBMS data model, you have to create a data model first, right? Before working, you have to create a data model first, and that data model is very rigid. Changing that data model is a huge task or an effort, right? Sometimes you may have to migrate data, and sometimes you have to adjust a lot. But in case of NoSQL, your data model can evolve with your use cases. Okay, it is evolving. It has actually trust on the evolving data model, right? Auto sharding and elasticity. They typically support automatic sharding, and they scale elastically. Highly durable. So a cluster of nodes represent a single large database as a highly durable database. Easily scalable. So scaling up is very easy. Adding a node should not incur, should not be a complex operation, and it should not have, a significant downtime, or no downtime at all. It should seamlessly support scaling up or scaling operations. So when I say elastic scaling, so it includes both scaling up and scaling down. Integrated caching. So guys, because this is distributed database, right? If you're going to have an external caching layer, then you will have issue with the rebalancing of data across nodes. So it is always recommended to have an integrated caching system. Okay, your database should support integrated caching. So type of NoSQLs. So we have basic, NoSQLs are, typically divided into 4 types. We have key value store. Key value store, we have a key and a value associated with this. Okay, value can be as simple as a string, or it can be a complex object also, right? Document store are similar to key value store only, but the difference here is corresponding to a key, there is always a document. Document may not be your Word file or word processing document. Typically it is JSON, or most popular is, you may be knowing, is MongoDB, right? So MongoDB is a document based database that support JSON type of structure. Okay, so we always have a document corresponding to a key. Then we have column store. Guys, column store I'm not covering here in this slide in more detail, because Cassandra is columnar store, and we'll talk about it in detail. Okay, how Cassandra works. So guys, column store is something, where data is represented in columns. Okay, and basically data is presented in rows, and rows have variable number of columns. Okay, so row 1 may have C1, C2, C, but not C3, C4, C5. Row 2 may have C1 but not C2, C3, C4, C5 but not C5. Now you can caution me. I guess, isn't it not similar to RDBMS? Right? In RDBMS also we have row, and in RDBMS also it's possible we do not have any value for particular rows. That is quite possible, right? But guys, there's a difference here. Okay, in a columnar store, row can have variable number of columns. Probably it will have C6 or C100 till C100. And this guy, let's say row 5, may have only C1. And guys, there's a huge difference when I say the value is not there in RDBMS and value is not there in columnar. So the difference here is, in your RDBMS, even if you do not have value for C2, it will be saving space for C2, right? Because you may insert it later. But when it comes to a NoSQL, if C2 is not there, it's not there in the storage also. It will never save space for this guy. Okay, so this is the basic difference. Okay, right guys, don't worry, we'll talk about it in more detail. Okay, graph databases are the databases that represents entity in terms of nodes, and sometimes they are not the actual databases, they are just graph processing engine. So for example, you can take example of DSC graph. So what is DSC graph? DSC stands for Data Sets and Enterprise. So it is a graph processing engine built on top of data stacks Cassandra. Basically, graph type of databases are the database that represent the entities in form of nodes. So let's say this is a entity called person. We have Alice and Bob. They are represented in terms of nodes, and these nodes may have some attributes like ID, name, age, and because these are entities, so they may have some relationships, and those relationships are represented in terms of edges, right? Edges or arms. These arms can also have attributes. Let's say relationship between Alice and Bob is Alice know Bob, and attribute of this relationship is label is knows and since when. Okay, and it can be two ways also. Okay, probably Alice knew Bob since 2001, but or one day before then Bob got introduced to Alice, right? So date may change. So again, a person can be again, it is not required that entity will be of single type. Maybe there is one other entity, that is group. That's a chess group. So what is the relationship between Alice and this group? Alice is a member of chess group. So basically, if you think about it, how it is arranged, maybe we have a data called people or person, database called person, or table called person, where person's data will be there. Then we have a group data, then we have a membership data, probably we will have a relationship data, right? By parsing all this data, my graph processing engine is creating this view. So now let's talk about type of data or structure of data. So data can be of four type of structure. Okay, first type of data is structured data. So structured data is basically the data that is in form of table. It has all the attributes have a specific data type. It is well formatted and structured. Most of the time it is tabular data. Either it is tabular data, or with very little effort it can be converted to the tabular form, in a tabular form. Okay, second is semi-structured data. So it is again in form of textual data file with a noticeable pattern. Noticeable pattern means it follows a strict pattern or strict format, like XML. XML has a XML follows a strict schema. So what is the point here, guys? If you have a schema about a database data, then that enables its passing. Okay, like Excel files. So this data can be very easily converted to this data. Okay, with very little effort. Third is quasi-structured data. So this is again textual data with erratic data formats. Uh, so for example, let's say you have a FB post, you have a tweet, you have some files containing emails, you have some chats, you have some server logs, right? Format is very complex, so you require specialized tools, you require some effort, you require some time to parse this data. Fourth and the last one is unstructured data. So data that has no inherent structure. It is typically stored in different type of files, right? And but it basically particularly there is no inherent structure. So typically in one of the definition of big data that you can find on Google, okay, uh, I think you gave it to uh, now one of the definition is now the unstructured data is growing. Okay, and this accelerated growth of unstructured data is what has become big data. Okay, so this is one of the definition of big data. So guys, we'll come to this one. So guys, before discussing Cassandra, let's talk about cap theorem. So guys, I know you have worked a lot in with RDBMS. If I want to evaluate an RDBMS, how do I do that? If I want to evaluate that, okay, this is the perfect RDBMS, how do I do that? So ACID is basically a compliance that is typically used to evaluate a RDBMS. Okay, so a perfect a perfect RDBMS should comply with these properties. A stands for atomicity. Guys, for I'm not that good with spelling, so if I do some spelling mistake, please pardon me. C for consistency, I for isolation, D for durability. So you can view them in detail. I'm not explaining them because that's not our intention. Okay. Okay. So basically, to evaluate one RDBMS, we have ACID compliance. So for NoSQLs, or for to evaluate a distributed data system, we use CAP theorem. So CAP theorem, I forgot the year. This was coined by a guy called Eric Brewer. I forgot the year, honestly, guys. And it talks about three properties of a system. Okay, CAP, C stands for consistency, A stands for availability, P stands for partition tolerance. So let's first discuss what is consistency. Guys, first thing you need to understand is this is in context with a distributed data system. Okay, what is a distributed data system? When we have data spread across multiple nodes. Okay, so just think from that perspective. Now tell me, what is the meaning of consistency in a distributed data system? So basically, guys, consistency means if I have nodes, multiple data nodes persisting same data X at a point of time, I should get the latest copy of data no matter which node I hit. Let's take a scenario. Let's say I'm updating this X to X1. Okay. And just after this X1 is updated, if I randomly hit any node, all the nodes should give me the latest updated value of X, that is X1. Okay. So my database should always give me the latest updated data in respective of any node I hit. Now, second property is availability. So availability says that system continues to operate as expected even when some node goes down, some node fails. Okay. So if I have this node down, then also system should operable. Okay. The last one is partition tolerance. It says that system continue to operate as expected despite of network or message failure. So for example, let's say I have a system with 5 nodes: node A, node B, node C, node D, and node E. Now, these 5 nodes are connected to two different routers, let's say router 1 and router 2. Okay. Now, let's say there is a fiber link between these two guys, and let's say something happened and this link is broken. Okay. Now, if you think about it, all my nodes are available. Okay. But they are not connected. Okay. They are actually available, but they are not able to talk to each other. Probably if they are persisting the same data, if some change happens here, it may not be reflected here. So basically, my all nodes are available, but not consistent. Okay. So the partition tolerance says that my system should operate in these kind of scenarios as well. Okay. So it says that if these are the three guarantees expected from a system, if I say, L is a nice guy, it is his property, right? But he's not guaranteed to be nice guy. Okay. If he's having a rough day, probably he will not act nicely. That's a possibility. But if I say, I guarantee that L is very professional person. Okay. So no matter what is the situation, he will behave, or he will work professionally. So that is kind of guarantee, right? Not a good
Hmm.
example, but guarantee is something that is always expected from a system, no matter what. If the system is some nodes are down, whatever it is always expected. Okay. So CAP theorem says that if these are the three basic guarantees expected from the system. A large-scale distributed data system can give at most two out of these three guarantees. No system can give all three guarantees. Depending on which coordinate your system is. Okay, so guys, CAP theorem now can be, because you know that these are the three basic guarantees that you can expect from a distributed data system. And depending on which two a particular system gives, you can make your selection. You can evaluate a database, right? So let's talk about specific situation that is known as split brain situation. So what we discussed here, right? It is actually a split brain situation. So this is a situation when we have a cluster of n replica nodes in a distributed system. We may encounter a network partition. Some nodes are temporarily unavailable to communicate with each other. This situation is known as split brain situation. If a machine is a brain of your system, so there is a split created, between multiple parts of your brain. Okay, so guys, now let's talk about it openly. So when this split brain situation occurs, you have to choose between availability and consistency. So you cannot choose both. Okay, so now in the split brain situation, just think about it. Now all the nodes are available, but because they are not able to talk to. So guys, first of all, in a distributed data system, how do I ensure high consistency? In the simpler words, can I say that if I have, these three nodes that is replicating the same data. So if I have these three guys replicating the same data, can I say that if I'm writing some data, I will not say that transaction is succeeded until it is replicated to all the nodes or all the copies. So in this case, in split brain situation, right? I know if I'm writing some data in on node E, I will not be able to achieve the consistency because I cannot contact node A, B, and C, right? So I have two choices here, whether I deny the transaction or be unavailable, or this is the first choice. In that way, I will remain highly consistent, right? But choice two is, although 60% of my cluster is unavailable, but I still have 40% of my cluster, right? So I become available with whatever I have, right? And in that case, I will not be that much consistent. I will not be highly consistent. So guys, basically what it says is, in a typical distributed data system, availability and consistency are exist in mutual exclusion. Okay, so you cannot expect both of them. Okay, if you are willing to have a highly consistent system, in that case that will be less available. Okay, if you're choosing to be highly available, in that case you will have to compromise with consistency. Now let's take an example. Just let it load. It is saving. Okay, so guys, just give me some pointers. Let's say I want to adopt a distributed data system. So what are the basic properties you will look for, or what are the basic or most important property you expect from this system? So at least here we have this choice of drawing here. Okay, so we talked about consistency. Actually, you named consistency because we already had that discussion. But I have this survey with lots of people. So the first choice or first thing people say is high availability. So let's say you have three nodes carrying the same data. Okay, data X. Okay. Now, as we discussed before, if I want to ensure high consistency, so obviously I will be ensuring that whenever I'm writing this data, I'm changing this data, it has to be replicated on all the replicas strictly. Okay. So now, if let's say one of this node goes down, now let's say this node goes down. So what will happen? I will be unavailable. So guys, what is the point of having three nodes then? If I have a single node system, traditional system, okay, then also if one node was down, I was unavailable. Here also, if one node is down, I'm still unavailable. Then what's the point of having three nodes? So if your answer is backup, so instead of a node, I can have a cold backup also.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in big data analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job.
We go to the availability zone also. Across the availability zone, if I am looking at high consistency, definitely, or that high consistency, I will be looking consistency across AZs also, right? Availability zones also, I will be looking for that, right? So no matter how my data, how my nodes are distributed, if any one node is down, I will be unavailable. Then what's the point of having multiple nodes then? So I agree, if it is active, the same time you have only one active, in that case, yes, you can maintain the consistency. But still, here you are not scaling up in terms of load. Okay, right? Network, out of these 15 nodes, probably two will be busy in doing some background job. That's a possibility, right? So it will slow down significantly, right? So what I want to say is, having highest level of consistency may not be a valid ask always. Okay, so because it is becoming confusing for you because you are from a consistent environment. So let me just give you an idea. Okay, so let's say I have replication factor of 5. I will just give you an idea how we maintain high consistency in distributed systems. Okay, if I have 5 nodes, okay, so in an ideal or in a highly consistent system, whenever I write, I will be writing on 5 nodes. Whenever I will read, I will verify data or I will read from 5 nodes. All my read and writes will happen on these 5 nodes, right? Now, tell me, instead of 5 nodes, I say I will read or write on majority. Will it fulfill my requirement? So what is majority in 5? 3. And in case of Cassandra, this is known as quorum. So if I say I am reading or writing at quorum, will it give me high consistency? Just think about it. So whenever I am writing the data, I'm ensuring that I am writing on 3 nodes instead of 5. So it will significantly reduce my delays, right? So if let's say out of 5 nodes, one node is performing slow, still I have a good chance of having 4 faster nodes, or at most 2 nodes are slow also. In that case, my 3 nodes are performing fast, right? I'm writing on majority. So let's say during read also, let's say during write, these 3 nodes are updated. I'm telling the worst case. Okay, ideally all the nodes will be updated. In the worst case, let's say because I'm ensuring quorum or the majority, these 3 guys are updated. Okay, these 2 are not updated. So while reading the data, I'm still reading from majority. So I will be reading from these 3 guys probably in the worst case. So then also this node will have the latest data. I will still get the consistency, right? So in a distributed data system, can I say quorum is very much similar to high consistency, assuming all nodes are active? So what I want to explain here is quorum is the highest level of consistency you can expect from any distributed data system. Expecting all consistency level all is not a valid thing here. Okay, if you're using all, you are just killing one of the most important purpose of having distributed data system, that is high availability. So actually, these sessions are easier for freshers actually. So because in these kind of sessions we have to undo lots of things. Okay, so if we have some fresher or college graduate, he has nothing to be undone practically. Okay, so this session are lots easier for them. Okay, so we are not in mainframes. Okay, we are not in one systems. These concepts looks very fancy, very promising when you have only one node, when you have everything in one node. As soon as you go multi-node, I'm not by multi-node, I'm not saying 2, 3, 4, 5, or 10 nodes. I'm saying your cluster may be spreading across 500 nodes, maybe thousands of nodes. Means if you have that scale, expecting these kind of things, is it still valid, or is it still relevant? One more thing, I do agree there are certain use cases where you cannot live without certain things, especially related to consistency. Okay, so especially for transactional workload. Okay, so transactional workload is where you strictly require ACID compliance. Guys, if you don't recall that, just study about it. Okay, and guys, you need to understand this. These are distributed data systems. These do not follow ACID compliance. These follow cat theorem. Okay, so they will be. I'm not just talking about Cassandra. Every NoSQL or NoSQL or every distributed data system, you are never going to get ACID compliance. Okay, so if you require ACID compliance, probably NoSQLs are not a good choice for you, honestly, guys. Now let's talk about one more thing. So ACID compliance is a fancy word. Okay, it is a good, it is very nice to have thing, or in some cases like yours, it is must have, must to have thing. Okay, out of 100% of your data, data use cases, how much of it actually requires ACID compliance? Just think about it. Actually, I have worked on lots of system where we have transformed, legacy systems from RDBMS to NoSQLs. Okay, I have worked on lots of project of this kind. And in my current project also, we are kind of transforming Oracle to Cassandra. Okay, what we were at, I think 1.5 or 2 years back when we started working, we were 100% on Oracle. Okay, so if you have a transactional system, obviously you cannot just live with no only for all your workload, you cannot just live with or NoSQL. Okay, there is some point of data, no matter how much transformation you do, there will be some percentage of your data that is always transactional. Okay, and that requires ACID compliance, so that you cannot move out from an RDBMS. Okay, so what we did, currently we are at 40% on Oracle, around 40 to 50% on Cassandra, and around 10 to 20% on Postgre. So whatever we cannot offload to Cassandra, we are offloading it to Postgre. Okay, and our target is 10% to Postgre and 90% to Cassandra. So what I'm doing and what I want to mention is, you cannot fulfill, or you cannot do all the things with NoSQLs. Okay, so where they have a limit. Okay, they cannot, you cannot treat them as a transactional systems. They have certain limits. Okay, if you hit those limits, have small, just you need to identify that portion of your workload that has that limit, and you can still have an RDBMS for that. Let's go hybrid. We need to acknowledge here is, it is not just taking data from one data store, putting in some other data store. Okay, this is not just, you have an engine and you just replace the carburetor or, combustion chamber. It is not just like that. It is just like overhauling of the entire engine. Okay, you have to, you know disintegrate every component of it, and you have to redesign it from the scratch. So guys, if you see, the only, as I said, right, consistency and availability are mutually exclusive, and there are only one type of system that can ensure you both. What kind of system they are? RDBMS, right? Why they ensure both? Because most of the time, I'm not saying all the time, they are assumed to be inside a single box. They are, natively non-distributed in nature, right? So most of the systems, distributed system, you have to choose between availability and consistency. Okay, and depending on that, you have to make a choice which type of system you want. So by default, again guys, see, I'm not saying, if I say, see, Cassandra is AP, available and partition tolerance. So when it comes to a choice, Cassandra chooses availability over consistency. And, by that I can understand, because consistency is so critical for you. That's why you have hard time, right? When I say that it is available and partition tolerant, it is not hard coded. It is not, it doesn't have to be always like that. In specific case of Cassandra, in most of the NoSQL DBs, this is just the default behavior. You can override this behavior, and overriding technique depends on database to database. Uh, uh, so in Cassandra, we have a concept of tunable consistency. What is that? So again, as I said, if you want high availability, you can go for low consistency, right? So up to the extent you decrease the consistency, you will increase the availability in same constraint and, same proportion. So you actually have to make a balance between these two guys. Okay, so we'll talk about it. But as per the cap theorem, Cassandra is available and partition tolerant. So Cassandra is typically classified as AP system, meaning that availability and partition tolerance are generally considered to be more, sorry, that availability and partition tolerance are generally considered to be more important than the consistency. Cassandra can be tuned with the replication factor and consistency level to also to meet C, that is consistency. Okay. So what if split brain occurs? So Cassandra also provide a built-in and customizable replication which store redundant copies of data across nodes that participate in Cassandra ring. Okay, so basically, guys, I think this may be new term for you, but because you are already working on Cassandra, so what is ring? So when you have multiple nodes, Cassandra always assumes them in a ring. Okay, so that's what we mean by a Cassandra ring. We'll talk about it. Okay, so in the case of network partitioning, if quorum of nodes form a cluster, Cassandra stays available. So that is why I told, quorum is the maximum consistency level you should be expecting. Okay, although Cassandra have something called all also, in case you are as good as RDBMS, right? So in case you are giving all, even if one node is down, one replica is down, you are unavailable, right? But if you are quorum, so if majority of the nodes are available, you are still available. Okay. Consistency on nodes that are not in quorum is not kept, but they will be eventually consistent. So with the tunable consistency, Cassandra has one more concept of eventual consistency. So let's say you are on quorum. So let's say for a particular transaction, these three guys are updated, right? And these two guys are left. Okay. So under the under the scheme, you can say scheme of eventual consistency, Cassandra will ensure that over the time or eventually these two guys also gets those updates. Okay, it is not immediately consistent, it will become eventually consistent. Okay, and guys, if you ask me how it is done, so eventual consistency is just a concept. Okay, it is not a single technology or single process that ensures that. There are multiple process, there are multiple measures or way to ensure eventual consistency. Let's start with Cassandra. Talking about Cassandra, what is Cassandra? So Cassandra, the Cassandra's architecture. So Cassandra's architecture is based on foundation of peer-to-peer based dynamo architecture. So basically, let's first understand how Cassandra was evolved. Just give me a moment. Let me just attach my device, the writing device. So actually, Cassandra was initially designed. So Cassandra or Apache Cassandra, not it was not Apache Cassandra at that time, was initially designed by Facebook for their inbox searches. Okay, but later on, because this is every company's strategy. Instead of because Facebook is not an IT company, right? It means it is not a database company. So what they did is they just open sourced it so that everyone else can improve it for them. That's how it works in open source industry, right? So what they did is so if you think about it, for a distributed data technologies, there are two crucial parts of it. Okay, first part is the storage engine that defines how data will be actually stored on the disk, or what will be the life cycle of data, how data's life cycle on disk will be managed. And another thing is its distributed backbone. So distributed backbone means how, so because it is distributed, so there will be multiple nodes and those nodes will be communicating with each other. So distributed backbone says that how this communication across the network will happen. Okay, so these are the two parts. So what they did is this part they took from Google Big Table, and this part they took from Amazon Dynamo. So both of them are best in class technologies. So thus they just integrated best of each technology and created a new database called Cassandra. So it was clever enough, right? So again, few years after, they just open sourced it, and from 2009 or 10, it is one of the top level Apache project. Okay, so that was how Cassandra was evolved initially. So what is Cassandra's architecture? So Cassandra's architecture is based on the foundation of peer-to-peer based Dynamo architecture with data storage model from Google Big Table. So we'll talk about it in detail, but what do we mean by peer-to-peer architecture? So basically in any distributed technology, including the RDBMS, if they work in distributed environment, you will always find one node as active node and another node may be the backup of or passive node, right? Or in other words, one node may be a master node and another node may be a slave node. Or in other words, one node may be a name node or another node may be a data node. So, but in Cassandra, all these concepts are not there. When I say peer-to-peer architecture, it means that every node in Cassandra is same. There is no master, no slave, no primary, no secondary, no name node, no data node. Every node in Cassandra is same. Okay, so that has lots of benefits. We'll talk about it. Okay, so first thing is no matter how many secondary node, primary node you have. So typically when we have a primary node, in most of the technologies, primary nodes are replaceable generally. Or in some technologies it is not. So if primary is down or master is down, everything is down. On other hand, in some technologies, like I said, MongoDB, primary is there but it is replaceable. If primary goes down, one of the primary will be promoted to, sorry, one of the secondary will be promoted to primary. Okay, no matter what it is, but till this voting process happens, your system is down. In other words, where primary is not replaceable, if primary is gone, everything is down. Similarly, if you have name node concept also, right, in Hadoop. So if you have name node is gone, everything is down. There is a concept of backup or secondary name node also, but still, if both of them are down, everything is down. But in Cassandra, it will be operational till at least one node is up, because there is no master. Every node is same, right? So there is no single point of failure in Cassandra. So data is auto-sharded, that is automatically distributed across nodes using key-based sharding, which means that keys are used to distribute data across cluster. So basically, guys, in distributed technologies, there are two concepts. I guess you already know about it. One is sharding, other is replication. I guess you already know about replication. So replication is replicating the same data across multiple nodes. Sharding is distributing data across multiple nodes. So if I have 100 values, so what I will do is I will keep 1 to 33 here, 34 to 66 here, and 67 to 100 here. Okay, so this is known as sharding. Or if I say this node along with holding this value, it will also replicate 1 to 33. This is replication. Okay, we'll talk about it in more detail. So sharding in Cassandra is automatic. Sharding is automatic. It means that when you insert some data, some part of it will be a key, or let's say primary key in RDBMS terms. So sharding happens on the basis of this key. Okay, and it is completely automatic. You don't have to govern that. You don't have to configure that, right? It happens automatically. Another part is, another benefit of auto sharding is, if you are going to add one more node, you are not required to configure the sharding part of it. Okay, so if let's say the whole cluster is having 100 node 100 data points or 100 records, so you don't have to configure explicitly that what part this new node will be owning, right? So the cluster itself will distribute the data among themselves. On other way, if you already have a cluster, if some node goes down or some node you are removing, in that case also, rest of the nodes will distribute the data automatically. So that's what we mean by automatic sharding. And all these operations are supported without any downtime. So why Cassandra? These are some of the reasons why Cassandra. Fully distributed, no single point of failure, linear scalability. So what do we mean by linear scalability? I think we had a slide about it. Yeah, here it is. So this is a chart comparing performance of multiple databases with Cassandra. So like Cassandra, Couchbase, Sbase, MongoDB. So the vertical axis has operation per seconds, and it is number of nodes. So if you see in Cassandra, as number of node increases, your operation per second increases linearly. Okay, so this phenomena is known as linear scalability. Okay, and here you can see it is best in class. I will tell you why. So the secret behind it is peer-to-peer architecture. Because in Cassandra, because every node is same, right? So it is not like there will be a master node, all that traffic will be routed to the master node, then it will route it further. No, this concept is not there. Every node is equal. So client, specifically, your client application can hit any node for any transactions. So by this logic, if my one node cluster is handling, let's say, 1000 TPS, then if you add second node, it is another contact point for your application, and it will be nearly, if it is having the same configuration, it will also be handling 100 transactions per second. So your TPS are increased by twice. If you add one more node, it will also be handling 1000 TPS. So it is 3000 with 3 nodes, and so on. Then this feature is known as linear scalability. So this is little bit history of Cassandra. So was developed by Facebook, open sourced in July 2008. Apache accepted in the community in 2009, and it is top level Apache project since 2010. Okay, so influenced by Google Bigtable and Amazon Dynamo, we already talked about it. These are some of the features. It provides efficient writes. So if you ask me, one of the best or well acknowledged feature of Cassandra is it provide very fast write rate. Okay, secret of it is in storage engine. We'll talk about it. So that's why Cassandra is very good use case for some of the domains like IoTs or sensor data, because there you require a technology that is able to ingest lots of data in small period of time. It is highly available and fault tolerant because it provides replications. That's why it is highly available. If some of the nodes goes down, their replicas are there. It provides tunable consistency. We talked about it yesterday in cap theorem discussion. It has Cassandra query language. So it's strange, right? How a query language can be a feature of a database. It is something that is basic, right? It is a feature. Let me tell you why. So especially in year 2011 12 when we were working on Cassandra, at that time it used to have one protocol or query language that is known as thrift. So it was really good, but the issue was it used to show Cassandra data in the raw format. We'll talk about it in more detail in next session. Okay, that is just the column family session, column family. And during that time, like you guys, most of the people who are adapting Cassandra were from RDBMS background or SQL background. So even when I started, we were also from SQL background. So it was really tough for us. Okay, so if you are a solution architect, then and you have you have some choices to make in terms of technology. This is one of the factor you will think about, how I will scale my team up for this technology, right? If it has some query language that is entirely different from what they are using currently, so I know there will be some learning curve, and that was restricting the adoption, okay, of Cassandra. So during that time, community started a project called SQL, that is CQL, that is Cassandra query language. So what they did is they developed a query language that is around 90% similar to SQL.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in big data analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job.
Okay, and it was a boom. It helped a lot. So anyone who is coming from RDBMS background, they will just feel okay. It is almost RDBMS, right? So that's why it is a feature of Cassandra that when you interact with Cassandra, it is just like any other traditional database you have used. Okay, although it is just a pseudo layer, so it is not nowhere like RDBMS. It shows that it is like RDBMS, but it is not. Okay, we'll talk about it. Flexible data storage, it supports all data formats and all type of data formats: structured, semi-structured, quasi-structured, unstructured. Easy data distribution is really easy, and elastic scalability, we talked about it yesterday, right? I think this is covered. So again, best in class performance, fully durable, uh, set of cluster of nodes represent a single database, and that is fully durable. And it has the feature of integrated caching. So again, in a distributed database, it is a big concern that how you are going to manage the caching there. If you have an external cache, then rebalancing that is another headache, right? Tuneable consistency, we talked about it. Multi-master. So multi-master means each node is same and any node can treat as a master for a particular transaction. So the concept of master is there, but the concept of master is only there for a particular transaction. So when your client application hits a node of Cassandra, that particular node treats like a master, or it takes the complete ownership of that transaction. So for that transaction, that's the master node. Probably for the next transaction, your client may choose some other node, right? So this is multi-master and multi-data center. Guys, I guess I hope you people must have at any point of time must have implemented multi-data center databases in any RDBMS. I think you must have done that, right? So I don't know. You tell me, was it easy, tough, or it was okay? The configuration part. Why those issues are there? Because our traditional RDBMS, right? They are not natively designed for that. Okay. So what we have done is we have just over the time, as per the requirement, we improved them, we developed some add-ons, and we force them to work like this. Okay. But this is different in case of Cassandra or in most of the distributed technologies. They are natively designed for multi-DC, multi-data center. I will give you an example. We will see that if let's say you just download Cassandra, okay, you just download Apache Cassandra, okay, you do not do any configuration, okay, just unzip it, run it in your local. Do not do any configuration, and on that server just run a command called load tool status, okay. On top of that command, it will show one thing, that DC or data center is data center 1, okay. So from where it came from, I did not told it to be multi DC, right? So that is just a posture that shows that I am by default multi DC. No matter whether you configure it or not, I will assume myself in a data center. You don't have to do anything explicitly to make me data center compliant. So this is something, right, guys? What I want to say is, so from the first line of code written for Cassandra, they were designing a multi-data center database. Okay, so it is not like something is designed explicitly to make it data center compliant. It is from beginning and natively multi-data center compliant. Okay, so this is just a for college students is just a diagram that shows where Cassandra can fit in your architecture. So let's say there's a use case of a site called zoomin.com that shows airlines flight prices on real-time basis. So they have this web application supported by caching layer and database, right? So the entire database and caching layer can be replaced by Cassandra. So these are some of the use cases. It fits almost in every use cases, but majority are time series database that typically are used in IoTs or sensor data. But practically it fits in every data, in every use case. So now this is just a pictorial representation that will give you idea about centralized and decentralized architecture. So in a centralized architecture, let's say we have a post office. There we have 3 desks that are handling different functions. Okay, these 3 guys are specialized in their own area. Okay, now in the central hall, you have a person that may I help you guy. So a customer will go him. They will tell, okay, I need to do this, and this guy will route him to the particular desk. Okay, this is the centralized approach. In decentralized approach, what we do is in every desk, every person or every desk has a generic role. So every desk can handle any kind of work. Okay. So you do not require this guy, right? So any customer can go to any desk. One more benefit is, let's say there are more customer for letter and couriers. So this guy will be busy, right? But these people may be sitting idle. But in this case, if this customer sees that, okay, these two guys are pretty busy, so he can go to this guy also, right? So this is the benefit. Every node is identical. Peer-to-peer protocol is used that will keep them in sync, right? No special host coordinates activity. So that may I help you guys is not required. No single point of failure. So if your stationary guy is gone, goes for a holiday, if this girl goes for a holiday, the work is not stopped. Okay, other people can well handle that. Easier to operate and maintenance because all nodes are same. So when you are inducting a new person, because the training module remains same, so the induction is very easy. Okay, if you take this in the context of node setup or database, so because every node is same, so setup instructions or setup scripts for every node are same. You just have to, uh, fill some placeholders like IP address and host name, and your script will work for every node. So while planning a new node, you do not have to worry about that, how you are going to set up or which kind of node it is, or what kind of startup script you will, or setup scripts you will be using for a particular node, because all nodes are same, right? So this is, for DBAs, or people who maintain the infrastructure, it is a big advantage. Elastic scalability. So cluster must accept new node without major disruption or reconfiguration, right? Process should not restart. So it's not like, if you are setting up a new desk, you have to stop the entire office, right? It should not happen. So if you are setting up a new node, it should not mean that you have to restart the entire cluster. So just imagine, a few years back, we were working for Apple. So Apple used to have Apache Cassandra client that they were moving to DSC. So their volume was, they were adding, at least few nodes every week. Okay. Uh, they had multiple clusters, Apple Pay and for other domain also. So just imagine if they are adding 2, 3, 4 nodes of each every week, and they have to, and size was in hundreds. Okay. And on addition of every node, if they have to restart the entire cluster, just think about it, what it will be like, right? Do not have to change the application charges. So you are even adding a new, after adding a new node, you are not required to change the application configuration, right? Do not have to rebalance the data. So you don't have to tell the cluster, okay, I'm adding a new node and this node will be handling this, right? So like our post office example. So if a new person is joining the team, if a new desk operator is coming, you don't have to tell other guys that, okay, this new guy is coming and this will be handling your stationary work. No, because everyone knows that we are all same. So this will be doing whatever we are doing, right? So high availability and fault tolerance. So no downtime is there. If a person is gone on holiday or on leave, so other people are doing the same work, so they can handle the load. Tunable consistency. I guess we talked in detail about it. So you have always option to choose between high availability and high consistency, right? Adjustable for read and write operations separately. So again, this adjustable nature, it is not configurable for the entire system. You can configure it on individual read and write requests. Conflict are resolved during read as focus lies on write performance. We'll talk about it. So guys, it is obvious, right? If you have multiple nodes and these nodes are replicating same data, right? So there will be times when this data across multiple nodes are inconsistent, right? So in Cassandra, because writes takes the priority, so all these conflicts are resolved during reads. Okay. Configurable and based on the application requirement. Again, these availability and consistency are configurable. High performance. Cassandra was designed to take full advantage of multi-processor, multi-core machines as to run across multiple machines present in multiple DC. So I guess, guys, you must have that idea. Do you know in what programming language Cassandra is written? Actually, most of the people think that, but it is Java. Okay, if you have set it up, it demands JDK, right? So it is written in Java. It runs in JVM, but and Java may not be the best, but it is one of the leading or one of the best technologies for multi-threaded programming. Okay, for enterprise grade applications, right? So because being written in Java, it takes full advantage of multi-processor and multi-core machines, right? It scale constantly and seamlessly to hundreds of terabytes, so shows exceptional performance under heavy loads. So also writes are extremely fast on basic commodity hardware. So this is the benefit, and this is the real one, guys. So or if you have bad experience with Cassandra also, then also you will agree on one thing, that all the troubles you got, 90% of them you will you will face in reads. Okay, writes are really fast, even with a basic commodity machine. Okay, so this is the similar graph we had seen. So where to use Cassandra? So when there's a use case of big data, database to run on commodity hardware at reasonable cost and still delivering the required performance. Wide columns are required, so your rows are really wide. Maybe each row may be containing each row may be containing millions of columns. That's a possibility. High velocity writes and reads. Guys, this is important. No secondary indexes are needed. So this is the area where Cassandra does not do very good. So Cassandra does not well support the ad hoc queries. Okay. Cassandra is only designed best for query on the primary key fields. Okay. So if you have employee ID as a primary key field, it effectively support query on ID only. Okay. You cannot force it to query on name like most of the RDBMS. It's not there. Okay. So if you do not have that use case, then that is good. But if you have it also, we have some modeling technique by which you can still do that. No need to run your application in active mode in more than one data center at the same time. Database designed to deliver as close as 100% uptime as possible. Okay, so these are some of the use cases: time series, e-commerce, feed-based feed-based activities, right? So this slide will give you an idea where Cassandra is a good use case, or which cases are good for Cassandra. Okay, now the more important slide is where not to use Cassandra. Okay, so when you require multiple secondary indexes, then you should not use Cassandra. So when you have a use case of relational data, so we talked about it. So if you have some data that cannot be denormalized, then probably you should not move it to Cassandra. You have transactional workload. By transactional, I specifically mean you require commit and rollback. Cassandra or any distributed technology will never give you this. There are some provisions in other technologies, but not so far in Cassandra. Okay, if you require these two guys, so Cassandra, that use case is not good for Cassandra. Okay, stringent security and authorization need on data. It is because Apache Cassandra does not support sophisticated authentication mechanism. Apache Cassandra supports just internal authentication mechanism. If you are looking some higher some sophisticated authentication like LDAP or Kerberos, probably you will have to go to the commercial version of Cassandra. Okay, searching column data or financial reports. So these are the use cases where you should not be using Cassandra. Okay, so again, actually, I hate this slide a lot. I will remove this. Let me tell you why. So, in any course you go, in any Cassandra NoSQL course, what they will do, let's find the similarity between RDBMS. But what I don't understand, why to do this? Your NoSQL is NoSQL, it is not RDBMS. Okay. So my thinking is never compare these two guys. Okay. More you compare, it will be troubling for you. If you are learning this, learn from a empty mind. Okay. So just skipping this slide, guys. Okay, this is the overall picture. So this is the node. Node is where your data goes. It is the physical layer of your data persistence. Okay. Then we have a data center, that is collection of related nodes. How they are related? Maybe they are on the same location. Cluster. What is a cluster? Cluster contains one or more data center. It can span across multiple physical locations, right? And above all, there is something called token range or token ring. So any data you add inside Cassandra, it will have a place in this token ring. Okay, and each data center owns the complete token range. Okay, so by this color coding, you can just predict that these token ranges belongs to some part of these token ranges belongs to a particular node in the Cassandra database. Okay, so just an idea, we'll talk about it in more detail. Yeah, so before that, let's try to understand, or let's start understanding or discussing the Cassandra data model. So guys, data modeling in RDBMS is easy. Not that easy, but easy in the sense what you do, you just create conceptual data model, logical data model, physical data model, and once you create the DB, you start working on that, right? But Cassandra data model is little bit complex. So if you want to truly understand Cassandra data model, you have to do it in 3 layers. Okay, you have to understand that in 3 layers. First of that layer is the clustered or level is cluster level. So in this level, typically we understand how data is managed across node at cluster level. Okay, what are the techniques for and what are the technologies that does that? Okay, second is at SQL level, or let's say database level or partition level, you can say. So there we discuss when you create a table, or in Cassandra terms, when you create a column family, how actually data is stored or managed. How Cassandra stores this data, it is entirely different from this view. Okay, and that is, if you want to create a good data model, that is really important to understand. Okay, so yes, it will be a very tensed session, or very deep session. Okay, there we will understand that. And third and the final layer of your Cassandra data model is the storage layer. In storage layer, we talk about how data is actually persisted on the disk, in what format, in what file format, and how life cycle of the data is maintained on the disk. And this course is unique. I'm not boasting, but this course is unique because you will not find all these 3 layers anywhere. I'm not sure because I have not attended any Cassandra course formally. I did that in 2012, when my organization was adopting Cassandra. At least I was the trainer was from very reputed organization. He was one of the contributors in linkedin.com, but even he did not explain me all this thing. Okay, and all this content is purely designed by me. Okay, this is not something I have taken it from somewhere. I'm teaching you. All this content or all these methods are designed by me. Okay, so let me know if you have any feedback. That will be a good one and will help me to improve. Okay. Okay, now let's first understand what goes inside a Cassandra cluster. Okay, I know this is not that useful for you guys, but this is part of the course. So let's discuss. Okay, so let's say this is my Cassandra cluster. Okay, so guys, I have this obsession to draw it perfectly. So just allow me 2 minutes to count the rows. Okay. So let's say this is my cluster and let's name it my cluster because this is mine, right? So this is my cluster. So let's first discuss what goes inside this cluster. So in a cluster or in a Cassandra cluster, I can have multiple data centers. Let's say I have data center. One is in States and another one I have in Europe. Okay, sorry, just give me a moment. Another one one I have in States and another one I have in Europe. So I hope you guys already know about it. What is a data center? So data center is the, I guess you both have read about this term, right? Geo read. So data center is the basic means of implementing geographic redundancies. Okay, so whenever you want to be redundant over multiple geographies, you implement GeoRed. And you implement that. So basically, GeoRed is just a concept. Data centers are implementation. Okay, so there can be multiple data centers in our Cassandra cluster, and they may be connected through a network. So in case of multiple continents, it may be over internet or VPN over internet. Now let's discuss what goes inside a data center. So what is there inside a data center? Tell me one thing, why we are discussing racks here? So it is just a database, right? Why my database is required to be aware about my racks? Reason is, if see, it is completely optional, okay? But if your database, especially Cassandra, know about your rack, so let us first define rack, because all the nodes in rack have same power supply, or they may be connected to the same router, right? Or we can also name them as a failure groups, right? So if your database is aware about your rack configuration, so while replicating the data, let's say it has to make 2 copies, it will try to put 1 copy in a node that is in rack A and another copy that is in on the node that is on rack B. Okay, so that's why providing this information precisely, it is always in our favor. Okay, we are just improving our availability at one new level, right guys? So inside a rack we can have multiple nodes. Let's say node 1, 5, yeah, 6, 7, 8, 9, 10. Okay, so similar architecture in data center Europe, right? So guys, whenever it comes to multi data center, obvious question is how they will work, whether they will be active or active passive, whatever configurations are possible, right? So there are multiple type of configurations possible. Let's say I am working, this data center belongs to Bank of America, right? Now Bank of America, I guess they have most of their business within US, right?
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in Big Data Analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job.
Probably 90% of their business in US. So why they want to maintain a data center overseas? Probably they were doing some business in some small European country, and the government offer a cheap real estate at electricity at the cheap rate to set up one premise there. And what they thought is, okay, anyways, we were thinking to establish a georet site remotely. So let's utilize this. If we do it in any other state of US, it will cost us at least 10 times more, right? Labor is also cheap there, right? So they just set it up. So this is their active data center where most of their traffic is going, and this is just for backup, right? So this is one of the scenario. Now, this is just like two main configuration, active, and active and backup. Okay, but there is third more configuration possible. Now, let's say I'm again Bank of America, and I have a particular credit card. Okay, what I observe is this card is really good for, people use it a lot, but most of the people, 60% of my transaction they do in the supermarkets. And I'm actually not getting a diversification of transactions. Okay, so what I got is I have a huge data of two for spent analysis. Probably I got it from other banks somehow. Okay, and I want to analyze that to drive some statistics like what are the percentage of spent across categories, right? If I have an age group of, let's say, 20 to 30, so probably this age group will be spending a lot on, clubs, pubs, bars, right? 30 to 40 will be, this is kind of family time, so they must be spending it for EMIs, right? Home EMI or taxation purpose or supermarkets. 40 and above is again kind of, luxury time. So basically, I want to identify what each age group uh, does maximum type of transactions in which category. Okay, so for that I need to analyze lots of data, and that data will help me to project right type of card for right type of audience, right type of customers, right? So this is a huge job, right? I have to analyze so many records, billions of records, right? So again, if I run it here, right, it can impact my primary business, my money transactions, right? And but I know I have a remote data center. I set it up, and that is doing nothing for me, right? And this kind of analysis, I know if I'm analyzing 1 billion transactions, okay, in this kind of analysis, who cares if I miss some thousand latest transactions? Nobody actually cares, right? It will not have that significant impact, right? So is it very much, it make much sense to run that heavy analytical or reporting job into my remote data center and keep my primary data center free for that, free for my primary workload. So this is another kind of configuration where you keep your primary data center for your primary workload and use the remote data center or backup data center for your analytical workload or reporting workload, right? Remember the times whenever we used to run heavy reports in the off-peak hours, right, guys? I guess all of us have seen that, right? So if you have this kind of configuration, you don't have to wait for off-peak hours. So there is one more concept. So we all know replication, right? What is replication? Replicating the same data across multiple nodes, right? What we achieve by replication? High availability. Do you agree on this, guys? So, and it has a huge cost. We have to agree on that, right? When setting up new storage server, it is a huge cost, right? So again, our availability requirements are not absolute. It depends on many factors. Okay, so let's say again for Bank of America, this is my primary data center, right? And this is just my backup data center or my analytical data center, right? So in my primary data center, probably I would like to have more availability. So probably I will be in position to afford more replication, right? But in case of my backup data center, I can still live with less replication to save the cost. So so it is very much possible to have different replication configuration for different data centers. One more aspect of it is, let's say I am a bank and I have two type of databases. One is the customer database and another is my HRMS database. That is, that is persisting my, employee records, employee payroll records, employee attendance records. So let's say I am a bank employee, right? I come to bank and I just punched in my, the biometric, sensor to record my attendance. Okay. Let's say my database is unavailable and I'm not able to do that. So will it be that big problem? So because my manager knows that attendance system is not working, it will not be that big issue. Okay. Still, it will not stop the bank working, right? It will not cost bank financially, right? But if I'm a customer and I'm not able to see my balance, then it will be an issue. Or if I'm not able to withdraw money, it will be a bigger issue. I require more availability here for the customer database. So within a database also, multiple domains or multiple type of databases may have different availability requirements. Probably there you want bigger replication, and here you can still live with lesser replication, right? Remember, replication has a cost, and that is not something you can ignore. This is very significant cost. Okay, making this 3 to 5, it will save lots of dollars. Now let's understand how Cassandra distributes data. Okay, now let's say I have a Cassandra cluster, and this is a simple cluster having only one data center. Now let's say this cluster is having 3 nodes: node A, node A, node B, and node C. So let's say I want to store some 100 values in this cluster. So what is the most efficient way to do that? I guess I will store values 1 to 33 here and 34 to 66 here and 67 to 100 here. Okay. So that is the most efficient way, where every node will have nearly equal amount of data, right? So in other words, can I split these values in some range from 2? Okay, let's say I have range R1, R2, and R3, and this one is from 1, this one is from 34, this one is from 67, 100, 66, and 33, right? So now I can say node A owns range 1, node B owns range 2, and node C owns range 3, right? Now, is that fair to say? So this is exactly how Cassandra stores data, or Cassandra distributes data across the cluster. Additionally, Cassandra assumes every node in a ring. So what it assumes is a ring of some tokens. Okay, I have 100 tokens. So whenever you insert some data, one of these token will be assigned to that particular data. Okay, and depending on the token, it will be decided from which range that particular data belongs to and on which node it has to go. So by this logic, Cassandra assumes every node in a range on this ring, where node A contains everything in range 1, node B contains everything in range 2, and node C contains everything in range 3. Right, guys? So this is basically how Cassandra distributes data across multiple nodes. So now let's try to understand how Cassandra writes data. Okay. Now let's say again, I have the same cluster, same Cassandra cluster, having only one data center, right? Now let's say I have 3 nodes in this cluster. So I will copy the node from here and ranges from here. Now, let's say I want to write some data here. Okay. So let's say how data is actually inserted in any database. So obviously it will be through some application. So let's say I have a HRMS application that stores my employees data. And let's say, for example, that is a Java application. So this is my Java application that want to insert some data. Let's say employee ID 1 and employee name John. Okay. So now this data has to be inserted into this cluster. Now, obviously, this node or this application has to insert it at a node, right? So it was if it was a master slave architecture, it was easy. So this node would have just connected or transferred this data to the master node, and it was super easy. Master node would have taken care of that. But in case of Cassandra, there is no concept of master node. So definitely, obviously, this application can hit any node for this transaction. So now let's say this node chooses node C for this transaction. So in this node is known as a coordinator node. So what is a coordinator node? Coordinator node is a temporary designation given to a node, or coordinator node is the node that is chosen by your client to conduct a particular transaction. Okay. And what is the role of coordinator node? Coordinator node takes the responsibility of that particular transaction, and it is his responsibility to complete that transaction. Right, guys? So it will just take the data, it will persist it, and it will give the response to the client saying that your transaction was successful. Client doesn't need to know how and where the data is inside the cluster. Probably on next transaction, your application is free to choose another node as a coordinator node. What is coordinator node? So coordinator node behaves like a master node for a particular transaction. Okay, now this node has got the data. Okay, now it has to decide where to put this data. So for that, every node has a component called partitioner. So what is a partitioner? Partitioner will be given the key part of the data. Let's say my primary key is 1, that is employee ID, right? It is given the key part of the data, and it will just give a token. Let's say my token is 25. So now, depending on this token, my coordinator node will decide where my data has to go. So from this table, can you tell me this token belongs to which range? No, range 1, right? And who is the owner of range 1? Node A. So depending on that logic, this node will stream the data to node A. Node A will this data. And guys, every column is persisted with a timestamp. Let's say T1. Okay. And after it has persisted the data, it will just say, okay, that the transaction was successful. And the same successful status will be given to the client. So this is the simplest workflow of how Cassandra, Cassandra cluster persists data. Let's say my replication factor is 2. So obviously, my data will be replicated on 2 nodes. Okay. Now it is fine that primary range owner will have the data, but who will be the next one? Who will be the next node to persist this data? So basically, now this ring concept comes into place. What it does is, it will just move clockwise in the ring, and it will choose the next node in the ring as a replica node. Okay, so it will just again go clockwise in the ring. And which one is the next node? That is node B. So it will place the replica on node B. Now, by this logic, am I not contradicting myself? Guys, I told you, right? Each and every node is same and all that masterless stuff, right? Am I not contradicting myself? Because more I think about it, what I feel is by this logic, this node is kind of master node for this data, right? And this is just like copy of it. I think I'm contradicting myself. So let me just correct myself. Okay. So this actually doesn't happen like this. Okay. This concept of primary range ownership is just for calculation purpose. Okay. So let me erase some stuff. So this concept of primary range ownership is just for calculation purpose. Okay. Because it need to fix some reference, right? So what happens is when data comes to the coordinator node, it will just calculate the token, right? It will find the primary range owner, that is node A. Then it will go clockwise to find out which one is the replica node. After this calculation, each and every node is same. Okay, there is no concept of primary copy, secondary copy, original copy or photocopy, primary owner or the secondary owner. That concept is not there. After that calculation is done, your coordinator node streams the data to all the replicas with equal priority, irrespective of anything. So this primary range ownership is just for calculation purpose. I'm repeating it. Okay. After that calculation is done, each and every node is same, and my coordinator node streams data to every replica, no matter how many replicas are there. It will stream the data to all the replicas with equal priority in respective of any factor. Now, let's talk about how it will send the acknowledgement in case of replication. In case of replication factor 1, it is easy. It will just stream the data to one node. When it gets the success, it will just give the acknowledgement. Okay. So now let's discuss how acknowledgement works in case of multi replication factor greater than 1. So when you are replicating, acknowledgement depends on the consistency level, heavily depends on the consistency level. There are 4-5 type of consistency level, but majorly there are 3 types. First is 1, second is quorum, third is all. And also guys, definition of consistency level is different in case of read and writes. In case of writes, definition of consistency level says that it is the number of acknowledgements your coordinator node has to wait for before branding a transaction either successful or a failure. Okay, so this step, if I number these steps, so this is my step 1, this is my step 2, this is my step 3. So notice that I'm marking both of these arrows as step 3. Okay, not 3.1, not 3.4, 5, not 3 and 4. Both are same. Okay, step 3 happens in respective of anything, including the consistency level. Step 3 does not depend on the consistency level. Now, how many acknowledgements it has to wait for depends on the consistency level. If my consistency level is 1, it will wait for one transaction and one successful result, and it may not be the primary one. Okay, let's say node B persisted the data, it says that your transaction was successful. Okay, then in step 4, it will just tell the client that transaction, whatever data you gave me, I have written that successfully. And this one may come offline, or probably it may not come. And that was the risk that I took when I defined consistency level 1. All is obvious. in case of all, it will wait for acknowledgements from all the nodes, all the replicas, not nodes. Okay. Now let's talk about quorum. Quorum means majority, and it is typically calculated by this formula: replication factor by 2 plus 1. So it is 2 by 2 plus 1, that is 1 plus 1, that is 2. So in this case, quorum and all has the same number, right? So by that reason, it is always recommended to keep replication factors in odd numbers so that we have a clear majority and clear quorum. Let's talk about some more concept. For that, I will just copy this one to another one to promote reusability. I will delete some of the stuff that we do not require for this one. So in the previous example, guys, we just discussed about the successful path. Okay, or the happy path when everything was okay. But what will happen when something goes wrong? Okay, so now let's say I'm writing on consistency level on. Okay, now during that or before that, at the same time, my node B goes down. So what will happen in that case? So in that case, when the transaction comes to node, so guys, again, there is a protocol called gossip protocol that is used to, for the process of heartbeat exchange between all the nodes of Cassandra. And we'll talk about it more, but let's assume that protocol is really awesome and it is very efficient. Okay, so whenever some node goes down, the information of that event is transmitted to every node within seconds, no matter how big is your cluster. Okay, just assume that for now. So now let's say if node B goes down, node C will get that information immediately that node B is down. Okay, so what will happen when this transaction comes to node C? Node C knows that, right? I have a consistency level of all to fulfill, and one of my replica or target replica is down, right? So definitely I will not be able to maintain this consistency level. So it will straight away throw an exception saying that not, oh, it crashed. It will throw an exception saying that not enough replicas available. So if you have managed a production cluster, you must have seen this exception at some point of time. Okay, so this is Cassandra's ways of saying is whatever consistency level you want, I cannot fulfill because to manage that or to implement that, I do not have the numbers. Okay, number of nodes up. Now let's say in this use case, I changed it and I want to say, okay, whatever it is, just try give me consistency level 1. Okay, so in that case, it will just write on node A. It will give the successful transaction, and your transaction is completed. And again, node B will not have the data. Okay, now the obvious question is, let's say after some time, node B comes back online. In that case, who will ensure node B should get the data whatever it deserves, right? Who will ensure that node B gets the data whatever it has missed? So for that reason, what Cassandra does is, so when something like this happens, it will it knows that, right, data was supposed to go on node B as well, but because node B was down, so I was not able to do that. In that guilt, what it will do, it will make a note. Okay, it will make a note saying that there was a transaction for node B, okay, with employee ID 1, that is my primary key for this primary key, and this was the data in form of stream. When as soon as your node comes back online, this transaction will be replayed and your data in node B will become consistent automatically. You don't have to do anything for that. It's free. Again, the entry it made here is known as a hint. And This overall process is known as hinted handoff. And if you just relate with the concept we just discussed, this is one of the way to ensure eventual consistency. Eventual consistency is just a concept. It is not a single technique. There are multiple techniques that ensure that. And hinted handoff is just one of them. After this hint is played, again, this data is deleted. Okay. Hints are not the only solution for your nodes going down problem. Okay, so hints are recommended to work for limited or shorter outages, and that shorter outage is defined by a configuration called hints period, and by default it is 3 hours. Okay, thank you guys. Thank you for joining in.
Just a quick info, guys. If you want to make a career in big data, then Intellipaat provides an advanced certification in big data analytics by ENICT Council IIT Guwahati. It is taught by IIT professors and industry experts. With more than 10 years of experience, this course is designed to upskill and land your dream job.